So we're going to start off this week by looking at law of sines. Okay, we'll finish up this law today, and then we'll focus on law of cosines tomorrow. So if we remember from last time, there's 3 cases you can use law of sines for. We're going to focus on the third case today, which is the 1 solution, 2 solution, or no solution. Okay. So here's your law of sines. Remember, it has 3 parts. You only use 2 parts of it at a time, and you set up a proportion. The way you can tell quickly if something is a law of sines problem without actually sketching it out and seeing what type it is if you make a table and you have a full row, then you know it's a law of sines problem. If you make a table and you don't have a full row, then it's law of cosines. All right, so other than just kind of reviewing what the formula is, there's not much else to explain, so we'll just jump into an example. So here's our first problem. And I would leave enough room in the beta, the gamma, and the C box, just in case there's a second answer. Now, I just said you can tell it's law of sines if you make a table and you have a full row. Well, we've got a full row. If you forgot that, but you remember the 3 different types, you can always make a sketch. And honestly, it's going to be helpful to make a sketch anyway, so then we can see what's across from what. So off to the side, make a sketch. Remember, my sketch is not to scale. It's purely just to put what's supposed to be across from what in the right area. So we got A is 6, put alpha across from it. B is 8. We're going to put beta across from it. And we don't know C or gamma. All right, so I put boxes around everything we need to find. And if you describe this using the 3 letters, it is, let's see, side, angle. If you knew gamma, then it would be a different problem. That would be side, angle, side. The angle would be between the 2 sides. But in this case, it's not. We'll talk about that case tomorrow. Any questions why this is side angle? Okay, no choices in what you do first here. What do you have to find first? Yep, so
beta.
Yep, you have to do beta first. Forget about that last row because it doesn't have any information in it, so you can't use it. All right, so let's see if we can set this up to find beta. Remember, law of sines always starts out like this. All right, so we got to find beta. Can anybody tell me what I can put on the left-hand side to set up the proportion? Yep.
Sine 35 over 6.
Yep, so we're going to do sine 35 over 6. Doesn't matter, you had to put that on one side or the other. So we put it on the left. And what's going to go on the right side? Yep.
Sine x over 8.
Sine of...
Well, sine of beta.
Beta over 8. Yep. Okay, so we're going to cross... Well, actually, we don't even need to cross multiply. Just multiply both sides by 8. Okay, and that'll get the sine beta by itself. Now, I'm not worried about reducing the 8 over 6. If that was a final answer, then yes, I would make it 4/3. But it's just something you're going to plug into the calculator, so it doesn't really make any difference if you press the 8 and the 6 button or the 4 and the 3 button. All right. I wouldn't reduce it just in case you make a mistake. All right, so that's equal to sine beta. And what do I do to now get beta by itself, John?
You solve 8 sine 35 over 6, and then you take the inverse sine of those guys.
Yep. So I'm never actually even going to figure out what 8 sine 35 over 6 is. I'm just going to plug that into the inverse sine and then see what that is. Okay. So I'll do it all in one step. All right. So let's type that in and see what happens. Now, does anybody remember what the domain of inverse sine is? In order for this to work, what does 8 sine 35 over 6 have to be between? Yep.
1 and -1.
Yep. And it's definitely going to be a positive number because the sine of 35 is a quadrant 1 angle. We know all trig functions come out positive in quadrant 1. So sine 35 is positive, 8 is positive, divide by 6 is positive. So this is definitely going to be a positive number. Just the question is it less than 1? Let's see. All right, so we got inverse sine, and notice I'm in degrees because that's what the angles were in. 8 sine 35. Make sure you close it there because if you don't, you're still changing the argument to the original sign in the numerator. Don't want to do that. And then divide by 6. Okay, so this is definitely a problem that has a solution. If it was a no solution, we would have gotten an error right there because the argument would have been bigger than 1, but it wasn't. So 49.886. I don't know why it does that sometimes. All right, so that's our answer for beta. Now, using this chart, I just explained that all of this comes out to a positive number. There are 2 quadrants where sine comes out positive. Quadrant 1, and in that case, it's the 49.886. So we have that. And where's the other quadrant where sine comes out positive? Yeah, quadrant 2. And what do you do with your answer from quadrant 1 to get an answer in quadrant 2? Think of the quadrant 1 as your reference angle. Yep.
You subtracted from 180.
Yep. I'm going to subtract that from 180. So I'm just going to write that off to the side. Or, I don't even have to write it down. We could just keep it over here. And if there is a second answer, it's 130.114. But we have to check if that answer fits in the triangle. What angle were we given to start the problem? 35. Could you fit 35 and 130 in the same triangle? Yep, that would only add up to 165. So this time, the second answer does work. All right, so what we're going to be doing now is solving 2 separate problems. We're going to use the same table to do it, but I want you to understand we're really doing 2 problems at the same time. And I'll color code it so you can kind of understand what numbers belong to, say, the first problem and what numbers belong to the second problem. The first thing I'm going to do is this. Once we know that something has 2 answers, then everything we have to solve for has 2 answers. You don't have to worry about what was given. The given is, that's done. Okay, we don't have to mess with that stuff. Just what we're trying to find. So now we're going to have gamma 1, gamma 2, C1, and C2. Everything that has a 1 is part of the same problem. Everything that has a 2 is part of the other problem. The A, the B, and the alpha are in both problems. And so if you wanted to kind of think about it, like color coding it, if that helps. A, or alpha, is in the red problem. Theta 1 is the red problem. And gamma 1. Those 3 angles are all in the red problem. Green problem has alpha, beta 2, and gamma 2. So the 3 green angles, those are all together in a different problem. And you could do the same with the sides. A, B, and C1. Those are the 3 sides in the red problem. And A, B, and C2 are the 3 sides in the green problem. So if you look, you should have 3 red sides, 3 red angles, 3 green sides, 3 green angles. So we're doing the red problem and the green problem. 2 separate problems. All right, so let's write down what we had for beta 2, 130.114. Now, we have a little bit of a choice about what we do next. We can either do this or this. Anyone tell me what we have a choice we could find next? Yep.
Gamma 1, 2 by subtracting everything by from 180.
Yep, we could do gamma 1 or we could do gamma 2. The thing is, you can't do C yet. Okay, we have to do either gamma 1 or gamma 2. Can you tell me the calculation, Tim, to get gamma 1?
Gamma 1 would be 180 minus 35 minus 49.886, which would be 95.114.
Minus 35 plus 49.886. I think that did sound right. I typed it in a little different than the way he said it, but I still typed in the same thing. I'm just going to add those two angles together and then subtract from 180. So that gives me 95.114. Now, you could finish off the red problem and do C1, but while we're doing the angles, I would just finish the angles first. Let's do gamma 2. Right, so Maddie, how would I do gamma 2?
130.114 plus 35 minus 180.
Yep. So that's going to give me 165.114, and I'll just subtract that from 180. And that gives me 14.886. Okay, so now we found 4 out of the 6 answers we need in this problem. Now your last step is to do C1 and C2. Order doesn't matter because they're 2 totally separate problems. Let's do C1. Now, C1, we called that the red problem. So you have to pick a full red row to do that problem. And technically you have 2. 2 red rows in this problem. Row A and alpha, that's a red row that has all the information. And B beta 1 is another one. Which row should I use? Yeah.
A.
Yeah. Why would you pick A over the B beta 1?
Because then you're not working off of data that you found.
Yeah, at least we're using information that was given. Numbers are a little nicer. We know they're right. So let's stick with that row. That's always the row you stick with when you do this kind of problem. The row that was given. All right, so sine 35 over 6 equals. And Lindsay, can you tell me what would go on the other side to find gamma 1?
Sine of 95.114 degrees.
Yep.
Over C.
5, 4 over C1. All right. And now we'll just cross multiply and solve for C1. All right, so I'm gonna do it all in one step. 6 sine 95 divided by sine 35. So 6 sine. The less rounding you do, the better. So don't try to do one calculation, round it, then do another calculation, round it. Just try to round all at the end if you can. Divided by sine 35. Okay, any questions on how I take that in with the parentheses? A little lazy on this last one here. I could have put this in. It doesn't really make a difference because I was done. So, but it's 10.419. So scroll back up. Okay, always remember what you were finding. That was a side, so you do not need a degree symbol on it. In fact, if you put a degree symbol, then that would make it wrong. So don't put a degree symbol. Okay, and C2. Now, how about Pythagorean theorem? We got A, we've got B. Why didn't we just use Pythagorean theorem to get C?
It's not a right triangle.
Yeah, this isn't a right triangle. This is close. So your answer would be close, but wrong. So don't use Pythagorean theorem. All right, so let's find C2, and that'll finish up. Start out with that same sine 35 over 6. Just keep using that. And what's going to go on the right side to finish this up and find C2. Nick?
Sine 14.886 over C2.
1486 over C2. All right, so let's see what we got. 6 sine 14,886. In fact, if I just bring up the last thing I typed in, I don't know if this is quicker or not, I just have to change this. 14.886, the divide by sine 35 stays the same. Okay, so 2.687. Now, the rounding we did there was to 3 decimal places on the test. I think it'll be pretty much the same. So if you're going to 3, your answer should come out pretty close to mine. Like you shouldn't be getting like 2.4. You know, that if you're getting the tenths place wrong, tenths place, and you go into the thousandths, then you probably mess something up. Okay, so any questions on that? Okay, so that's a 2-solution problem. That's the worst case, 2-solution. All right, let's take a look at one. Actually, you know what? Let me show you visually how you can get the 2-solution case. All right, how can you actually build a triangle that comes out with 2 different answers if you're given the same 3 pieces of information to start? Well, this is how. Let's take and start with this side, and I'm going to make a copy of it. By making a copy, does everybody agree that that side and that side are exactly the same? Okay, so I've got the side. So there's 2 triangles that have a side in common. Next thing I'm going to do is take this side, make a copy, and I'm going to flip it. Is it still the same length as the side I copied it from by flipping it? Yeah, there's no change in the length just by flipping it. So now that is the same as that. So now we have 2 sides in common. I don't really have many choices at this point. All I can do is just connect the 3rd side together. But they do have an angle in common just by doing that. Does anybody see what angle they both share? Yeah?
It's that one. The left one.
Yeah, that lower left angle. If I just take all this and group it all together and just move it up so you can see it for a second. Not perfect, but those 2 angles in the lower left are exactly the same. All right, so now this angle matches this angle. So I just drew 2 different triangles that have 2 sides exactly the same length and 1 angle exactly the same, but they're totally different looking triangles. 2 different problems. This is what just happened in the last problem. That's how it can happen. Any question on that? All right, let's look at this one. And let's see what's going on here. Since we're going to be doing law of cosines tomorrow, let's make a sketch and just make sure we understand what type of problem this is. So we've got A, alpha, B, beta, C, gamma. So using 3 letters to describe it, can somebody tell me what kind of triangle do we have here? Yep.
SSA.
Yep, it's SSA again. It's the same as the last one. 2 sides and an angle that's not included anymore. Included means between. So it's SSA. Unfortunately, that's the worst type because you got to check for the no solution, 1 solution, or 2 solutions. This problem that we just did, I call this a 2-solution problem. Everything that you had to solve for had 2 solutions. All right, let's see what happens here. Michael, what do I have to solve for first?
Alpha.
Yep, you have to find alpha first. If you've got a row that's empty, just ignore it. And we'll come back to it later. Okay, so let's set this up to find alpha. All right, Julie, can you tell me what I've put on the left side? Yep, so we're going to do sine 50 over 1 equals, and John, what's going to go on the other side?
Sine of alpha.
Anything else?
Okay. Which is 2.
Yep. Okay, so again, you don't even need to cross multiply, just multiply each side by 2, and you don't even really need to keep this divide by 1, because dividing by 1 doesn't change it. So all you're going to have is 2 sine 50 equals sine alpha. And Madison, to get alpha by itself, what do we do?
You take the inverse sine of both sides.
Yep. Take the inverse sine. Take the inverse sine. That's gone. And let's do the inverse sine of 2 sine 50. Inverse sine of 2 sine 50. Close my parentheses. This time I got a domain error. So assuming I did everything right, typed it all in right, what does that mean about 2 sine 50? Yep.
It's greater than 1.
It's greater than 1. Yeah. I know just from doing trig, the sine of 45 is 0.7. Just remember that, it's 0.707. Well, sine of 50 is a little bit bigger than that. So if I just take 0.7 and double it, I'm already at 1.4. So the sine of 50 doubled is even bigger than that. So it's not going to work. So that means that there is no solution for alpha. And just like the 2 solution case, all the answers either have 1 solution, they all have 2, or they all have none. If you can't find alpha, then you have nothing to add up and subtract from 180 to get beta. So there's no solution for beta. And if you can't get an angle, then you cannot get the side across from it. So this is a no solution problem.
I like these kind of problems.
Yeah, that's the easiest one. So you could have one like that on the test. And the way I would do it is I just set up like a drop down and say, tell me if the following problem has 1 solution, 2 solutions, or no solutions. And then I might say, if it has a solution, solve it. If it doesn't, well, you're done. Okay, questions on that one? So I showed you what happens when you try to draw the 2 solution. You get 2 triangles. What do you think would happen if I try to draw this? Mike?
It wouldn't be a triangle.
It's not going to be a triangle. Yeah. So let's draw it. What we need, and it doesn't matter what unit you use, but you basically need a side, and then you need one double the length of that. Because this side is 1, this side is 2. So let's call this 1, and then let's put a couple of them together and make something that's 2. So now you have a side that's, you can get it lined up, there we go. You have a side that's exactly 1 and a side that's exactly 2. Okay? That's all. So let me group those together. Now the side that is 2 units long, we're calling that side A. So here's a picture of a triangle. I didn't put the third side in. But here A is the one that's at the 50-degree angle. So this has to be at a 50-degree angle. And that is exactly 50. Okay, that's measure. The computer has a little tool where I can measure that out. I'm just going to try to put it, yeah, close enough. Okay, can't change that. Can't rotate that anymore. We've got to keep that at a 50-degree angle. Now the other side that they give me is side C. Well, side C is the one over here. Side C is 1 unit long. There's no restriction on how I rotate it because this angle up here can be anything you want. They didn't tell you what it could be when you're solving for it. But for some reason, I don't know why, and they still haven't fixed it, you can't rotate it. I don't have the little green circle thing on it. Unless I take it and I group it with something. So if I group it and then I delete it, now I have the little green thing where I can rotate it. I wish they would fix that. Alright, so you can rotate that any way you want. What you can't do is make it longer. It has to be 1 unit. This one, you can't do anything to it. It has to be exactly 2 units and it has to be at a 50-degree angle. Now, this side, I can make it as long or as short as I want. I can't rotate it because then that would change this 50. This is 50. Can't change that. But I can make it longer or shorter, and I can rotate this side any way I want. Well, are these two sides ever going to be able to meet? No. No matter how you do it, they're not going to meet. To have them meet, you'd have to be allowed to do one of two things. Either be allowed to make this side longer, or be allowed to make that angle smaller. And then I think you could make them meet. But without being able to do either one of those, we're stuck. And that's why it's a no solution. Any question on that one? All right. Let's try. I think there's 2 word problems, and that's it. So there will be a word problem on the test, but I will give you a diagram that helps you a little bit. So you won't have to draw it from scratch. Okay, just to kind of explain what's happening in this problem. Okay, somebody is trying to measure the height of an object that's far away. And they're going to stand in one spot, they're going to measure something, and then they're going to back up, and they're going to measure again. How much they back up is going to be a known distance. Okay, and that's the idea. So we're trying to measure the height of something by observing it from 2 different locations. So in this case, it says to measure the height of a mountain, a surveyor is going to take 2 different... Okay. So a surveyor is going to take 2 different sightings from the peak, and they're going to use a device called a transit, which you can look through. Sometimes you see them on the side of the road. People are measuring, like they got a tripod set up, and then maybe further down the road you see another tripod. They're usually measuring something. It could be measuring property lines, or maybe a pitch. If you're building a house, things like that. And the 2 different sightings of the mountain are going to be taken at a distance of 900 meters apart. That has to be a known distance. That's easy to know because you just stand somewhere, get in your car, use your car to measure how far back you drive, and then get out and measure again. So that's easy to figure out. The angle of elevation is basically the angle if you were like pointing a laser at something. Imagine the ground is horizontal. You imagine pointing a laser at a target in the distance. This is what that angle is. It's the angle you have to tilt that laser at to point exactly at the target you're trying to measure. So the first time the surveyor measures the angle, it's a 47-degree angle. Now they're going to back up. They're going to back up 900 meters, and they're going to measure the angle again. What happens to your angle of elevation to an object if the object is fixed, it's not moving? As you back away from it, does the angle, does it get steeper, or does the angle decrease? Yep.
It Decreases?
Yeah, it decreases. Just like, if I'm looking at, something fixed right there, if I get very close to it, I have to look up very steep, like a movie screen. Right? If you're right in the front, you'll look up very steep. If you move away from it, your angle you look at decreases. So the second time the surveyor measures the angle, it's 35 degrees. So those are really the two important numbers with the 900 that you need to know. Now the device they're using to measure it, it's called a transit, and that usually is on a tripod. So technically you have to take into account the height of the tripod. But for the purpose of measuring the mountain, the height of the tripod, maybe it's 5 feet tall, 5.5 feet tall. It's not going to throw our answer off that much. So we'll just assume that the transit was right on the ground, because that's where the angle should be measured from, on the ground. But the transit is probably on a tripod. All right, so we got a lot of information there. What do you think would be helpful to do with all that information to make this problem a little easier to think about? Yep.
Sketch it.
Yep, I'm going to sketch it. Can somebody tell me something important that's going to be in my sketch? You don't have to give me numbers. I'm actually thinking of objects. Like what are the objects that are going to be in my sketch? Yep.
A mountain?
And even before the mountain, something even more basic than that. Yep.
Triangle.
Well, the triangle is what's going to just kind of happen from drawing the objects. So don't think about making the triangle, just think about the objects in the picture. And the mountain is going to be one of them. Yep.
The ground that
Yeah.
the tripod's on.
Yep. You got to have the ground in there. So let's put the ground in. I think it said somewhere the ground was level. Level. And we need a mountain. So let's put our mountain. There's our mountain. It's pretty steep. Careful if you climb it. And we want to figure out the height of that mountain. Now, the surveyor is going to measure from two different spots. Let's say here and here. And each time they measure, they're pointing an object at the peak of the mountain to get an angle of elevation from that spot. So we're going to have two, I'm going to represent them as dotted lines. So that's the angle of elevation right in there the first time. And here's the angle of elevation the second time. Now we know something about this distance. How far apart are the two sightings? Yep.
900.
Those are 900 meters apart. This is our first angle of elevation. This is the second one. I'm not going to keep those there because I have enough numbers. It's going to look confusing. The first time that we measure the angle of elevation, we get, where is it? 47. Okay, so this is a 47. And what did we get the second time we measured it? Yep. 35. Okay. And remember, what we're trying to find is height of the mountain. That's what you want to know. Height is perpendicular, straight down. So if we had enough information, all we have to do is look at this blue triangle and solve it for h. But if we pull it down and look at it, oops. I don't know if we have enough information to solve for h. You've got a 47. You've got a 90. You could get this other angle up here if you wanted it. You don't need it. But do you have enough information to solve for h in that triangle? No, you've got to know a side. Okay, you can't figure out, you can't solve a triangle if you don't know any of the sides. You need more than just angles. So I'm going to have to come back to that one in blue. But what we can do is look at this one in red. It's not going to give us the height, but it's going to give us something that we can use to then get the height. So pull this one right here. And we know this is 35. How about that? I would rather know what that is. How could I figure that out? Nick?
Since it's on a flat line with another angle, those two angles have to add up to 180.
Yeah. So let's just minus that from 180. And that gives me 133, which in and of itself is not really important. But what is important is this. Very important. Why is that important? Well, in order to use the law of sines, you have to know an angle and the side across from it. Well, now you can figure out that angle. And then we can use law of sines to find something in the red triangle that will help us in blue. All right, so let's get that. And how do I figure out that angle up at the top? Yep.
35 plus 133, and subtract that 180.
Yeah, so add these up. So that's going to give me, what's that, 168? So we got 168 degrees between those two, which means the other one has to be 12. Now, what in that red triangle do you think I want to find? I'm only missing two of the sides, so it's one of the two. But which one do you think I want? Yeah?
The side all the way on the right, because it's equal to itself, so we can know that it's the same side as the one on the left on the blue one.
Yeah. Those two sides are the same side. So if I can figure out from the law of sines the length of the side using the red triangle, then copy it over to the blue one as the hypotenuse, then I can use Pythagorean theorem, right triangle trig, I can use whatever I want to solve the blue one. All right? So this is a kind of problem where you have to find something else first before you can find what they really want you to find. All right, so let's just call this x. I want you to get used to not always using a, b, and c, just kind of getting used to the idea of the formula itself. So can anybody fill that in for me and tell me how I would solve for x? Yeah.
Sine 12 over 900.
Yep, sine of an angle. Divide by what's across from it. That would be one row in your table. And then how about over here?
Sine 35 over x.
Sine of an angle. Divide by what's across from it. Exactly. And x is really the hypotenuse of the blue triangle. Let's solve for x. So we're going to have, let's see, 900. Let's clear that. Oops, clear that. So 900, sine 35, and then you're going to divide by sine 12. Again, just be careful with your parentheses that you type it in just like that. All right, hit enter, and we get 2,482.88. Okay, so that's the length of that side in red, which we labeled as x, which is also the hypotenuse of the one in blue. So now, 82.88. You could use law of sines to finish that off and solve for h. But if I have a right triangle, I prefer to just use like SOHCAHTOA or something like that. All right, so let's use this angle, this side, to solve for this side. What's the name of side h relative to the 47? Yep.
The opposite.
It's the opposite. And what's the name of the side that's 2,482? Yep. That's your hypotenuse. And what trig function has opposite and hypotenuse in it? Sine. So now, we can set it up. Sine 47 equals h over 2,482. 0.88. Okay. And our last step would be to do what on both sides?
Take the inverse sine. Oh, actually divide by 47.
Well, we're trying to get this by itself.
Divide by 2,482.88.
Well, we already have a divide by 2,482. So we don't want to have h divided by that. We just want to have h. So how do we get rid of a divided by?
Multiply.
Multiply. So we're going to multiply each side by 2,482.88. I'll just put it in parentheses so you know it's multiply. And that is the answer for the height. So it's 2,482.88 times the sine of 47 gives you a mountain height of 1,815.86 meters. 1815.86. Any question on that one? Yeah.
Could you have done angle side angle and gotten the same answer?
You mean law of sines?
Yeah.
Yep. Yep, definitely. You could do law of sines on that. So the whole point of that problem was basically making two different observations on a stationary object to figure something out. We're going to finish up with another problem, making two observations on a stationary object, but this time you're going to be able to find what you want right away. You're not going to have to find something and then use it to find something else. Okay. I think the hardest part of the next problem is, again, like the last problem. It's the diagram. This problem is a pretty standard kind of trig problem called triangulation. You're trying to figure out where an object is based on two different people observing it. So you're not necessarily finding the height of an object, you're more finding the location or maybe how far away an object is. But it's still the same idea. So the way this problem, you can kind of imagine what's happening is pretend like you've got two Coast Guard stations. Okay, this is at night, and there's a boat in the distance, and the boat, for some reason, they're lost. You know, it's cloudy, so they can't see any stars. Their radio works, so they radioed in, they need help, and they have a light. A lot of boats have like a light on, you know, big light on the top or something. So they turn their light on, and the Coast Guard station sees the light, okay, where the boat is. But the thing is, they have to figure out how far away the boat is, and that can be very hard. If you just see a little dot of light in the distance, you might not know, is that 5 miles away or is it 20 miles away? And that may make a difference, you know, you have enough fuel to send a helicopter or, you know, something like that. So they got to figure out how far away the boat is. And so that's what they're doing. So the ship sends out an SOS, again, using that light, so they can see the light on the boat. And each Coast Guard station, the Coast Guard stations are on a map. They know exactly where they are. So they can use a compass from where they're standing, just hold the compass and look at an object in the distance and say, okay, that object is at an angle of 20 degrees on my compass or whatever. So in this one, they see the light from the boat, from where they're standing, and it's at an angle that's 40 degrees east of north. So that's like northeast, almost exactly northeast. And then we have another Coast Guard station, and I think they tell us somewhere 120 miles away. So they can see the same object, but they're going to see it from a different perspective because they're looking at it 120 miles away from where you are. And they see the boat more in a northwest direction, okay, 30 degrees west of north. And the question is, how far is each station from the ship? And how far they are, that may influence which Coast Guard station sends out a rescue. Maybe they don't have enough resources to send both at the same time, so they can only send one, so they're going to send the closer one. Again, ton of information here. What do you think we can do to make this a lot easier to think about? Yep, make a picture. The goal is not to make a triangle. If you draw the picture correctly, the triangle will just happen. Okay, so don't think about making a triangle. Think about drawing the objects. So the first thing is we've got Coast Guard stations, which are presumably on land, and we have a boat, which is in the water. So we need land and we need water. Okay, so let's do that. So let's go like this. Let's make a line. On this side represents land. On this side is water. So our boat, there's our boat. They're out in the water. Okay, we're kind of looking at this, pretend like you're, way up above it and you're looking down. That's what we're drawing right now. We've got 2 Coast Guard stations. Usually they're right, maybe on the shore. So we got one over here. We got one over here. The boat isn't necessarily centered between them. We don't know that. But here's our 2 stations. Let's name them. X-ray and Zulu. I need to put them in the right spot. Zulu is to the west. So west means it's to the left. So let's call this one Zulu, X-ray. And they each see the same light on the boat. So let's put a dotted line in that's pointing right at the light on the boat. Alright, so say the light is right there and right there. You can see it doesn't necessarily make a 90-degree angle. It would be very, very rare if it did. Now, each station basically is going to observe the angle from their perspective to the boat. So think about it like this. Imagine putting a line right there that represents north-south, and another line right there that represents north-south. It says the call to station Zulu indicates a bearing 40 degrees to the east of north. Well, this is north. East of north would be this way. That's a bearing 40 degrees to the east of north. It's like saying to the right. Any question on that? All right, so let's put that in our picture. 40 degrees. Here's north. Here's east. 40 degrees to the east of north. There's your first bearing from station Zulu. How about X-ray? I know it said to the west of north, but can someone remind me how much to the west was it? Yeah?
Is it
30
30 degrees?
degrees. So again, here's north. West is over here. So west of north is 30 degrees. And the other thing, we need one more, how far apart the 2 stations are. This is like how far apart the sightings were in the last problem. What did it say in the last one was 900? What was the distance between the 2 Coast Guard stations? Yeah? 120 feet. Now, I didn't think about making a triangle, but it just happened. Right? Here's your triangle. So a lot of times what I like to do is once I see the triangle, trace it and take it out of the picture. So then you're not thinking about it as much like a word problem. And now you're just thinking about solving a triangle. Let's move it down right here. All right. I would like to know those 2 angles. I wasn't given those 2 angles, but based on what I have here, it should be pretty easy to find them. Yep.
90 minus 40, 90 minus 30.
Yep, so how much is the one in the lower left?
So 50.
50 and
60.
60. Easy problem now. Now it's just a law of science problem. In fact, it isn't even the case we studied today. This is angle sine angle. That's one of the easier cases that only has one solution. Which makes sense, because if you think about the boat, it's not like the boat could be here or there. No, the boat is in one spot. So there's only one solution to this problem. Right, let's call that A. B, you're never gonna, let's see, you're never gonna worry about C because you already have it. But do you need this angle at the top? If you're setting up law of sines.
Yeah.
Yes. You have to know an angle and a side across from each other. If you don't have that, then you don't have a law of sines problem. Well, 50 plus 60 gives me 110, which means the angle at the top is how much? 70. Right, and let's just set it up to find A and B. So find A, find B. We don't have to go through the calculation, but we should just set it up. All right, how about, Sophie, what would I do to find A?
A would do sine 120 over A.
Sine of
No, well, 60, sorry.
60 over A. So she put the unknown on the left, that's fine. And what goes on the right?
Sine of 70 over 120.
Perfect. 70 over 120. Cross multiply and you get your answer for A. And how about setting it up for B? Michael?
Sine of 50 over B.
Yep, sine 50 over B. Again, he put the unknown on the left, that's fine. And what goes on the right?
Sine of 70 over 120.
Same thing, yeah. Right, and now figuring that out, will tell you exactly how far each Coast Guard station is from the boat. And we've kind of simplified this problem because in real life, you know, unless the boat had an anchor, if it was a storm, they might be moving. So then that complicates it a little bit. You have to take into account the direction the boat is drifting. So if it's going to take you 3 hours to get somewhere and the boat's drifting at 30 miles an hour, by the time you get there, the boat's going to be 90 miles away from where it was when you started. So that could really be a problem too if the light burnt out on the boat. Now you can't even see them anymore. You got to kind of predict where you think they're going to be. Now it gets a lot harder. Okay. Any questions on that? Okay. So that is law of sines. Okay, so those are the problems to take a look at for tonight. So 4, 9, 11, 13. 14, 18, and 19. And don't think you're doing something wrong if you get a no solution. I will tell you there are at least 2 problems, I think, that have no solution. Maybe even 3. So there are a few with no solution, but then there are some with 2 solutions.